Radio control systems present viable alternatives for achieving long-distance on-off control without the need for physical wires. They facilitate wireless communication and can be implemented with minimal infrastructure compared to the labor-intensive process of trenching or plowing in a control cable. The benefits of utilizing radio control are firstly, the elimination of the need to install physical cables, which translates to reduced labor and downtime. Secondly, a capability to function over extended distances limited only by line of sight. Thirdly, the ease with which they can be relocated or expanded to accommodate changing needs. Fourthly, the potential to support multiple simultaneous control points. However, it is important to acknowledge the considerations associated with radio control. Firstly, a clear line of sight between the transmitting and receiving points is essential for optimal performance. Secondly, the range and reliability can be influenced by obstacles, interference, and weather conditions. Thirdly, a dependable power source is necessary for consistent operation. Fourthly, regulatory requirements may necessitate licensing and frequency coordination in certain areas. For sourcing radio control systems, you might consider exploring options from companies like RF Solutions, which can be found at https://www.rfsolutions.com. Wireless controls. Cradlepoint, specializing in industrial routers, is another potential source. Their website is https://cradlepoint.com. Products. Industrial routers. Intake Process and Analytical Instruments also offers radio control systems, accessible through https://www.process analytical.com. Products. Meters and instruments. Radio control systems. Conversely, trenching or plowing in a control cable represents a more conventional approach to achieving reliable control, albeit one that incurs substantial infrastructure expenses. The advantages of this method include firstly, a robust and dependable connection that remains unaffected by weather conditions or interference. Secondly, a reduced susceptibility to interruptions or security breaches. Thirdly, the capacity to transmit significant volumes of data or power. Nevertheless, it is crucial to account for the considerations associated with cable trenching or plowing. Firstly, it necessitates extensive site preparation involving trenching or plowing. Secondly, it can be both costly and time-consuming to execute. Thirdly, modifications or relocations can prove challenging. Fourthly, there exists the potential for damage resulting from animal activity or adverse weather events. Ultimately, the determination of whether radio control or cable installation is the superior choice hinges on the specific demands of application, taking into account factors such as cost, distance, reliability, and installation constraints. Radio control systems offer several advantages, particularly in situations where physical cabling is impractical or cost prohibitive. They eliminate the need for extensive trenching or burying of cables, reducing labor costs and minimizing disruption to the surrounding environment. Radio control systems can be deployed quickly and easily, making them suitable for temporary or mobile applications. They offer flexibility in terms of control points, allowing for multiple devices to be controlled from a single location. These systems typically operate on license-free radio frequencies, reducing the need for regulatory approvals and ongoing licensing fees. Radio control systems can be integrated with existing control systems, providing seamless automation and remote monitoring capabilities. Modern radio control systems employ robust security measures to prevent unauthorized access and ensure data integrity. However, radio control systems also have limitations. The range of radio control systems is limited by factors such as antenna height, terrain, and interference. A clear line of sight between the transmitter and receiver is often required for optimal performance. Radio signals can be affected by weather conditions such as rain, fog, and snow, which can reduce the range and reliability of the system. Interference from other radio devices can also disrupt communication. Radio control systems may not be suitable for critical applications where reliability is paramount. Cable trenching and plowing offer a more traditional approach to establishing control links, providing a physical connection between control points. This method offers several advantages. Cable connections are highly reliable and are not susceptible to interference or weather conditions. Cables can carry high bandwidth signals, making them suitable for applications requiring real-time data transmission. Cable connections are inherently secure, reducing the risk of unauthorized access. Cable installations can be designed to meet specific environmental requirements, such as resistance to moisture, chemicals, and extreme temperatures. However, cable trenching and plowing also have drawbacks. The installation of cables requires significant labor and equipment, increasing costs and extending project timelines. Trenching and plowing can disrupt the surrounding environment and may require permits and approvals. Cables are susceptible to damage from digging, construction activities, and natural disasters. The cost of cable repair can be significant, especially in remote or difficult-to-access locations. When evaluating radio control systems versus cable trenching and plowing, it is essential to consider the specific requirements of the application. Factors such as distance, terrain, environmental conditions, budget, and required reliability should be taken into account. For applications requiring short-range control in open areas, radio control systems offer a cost-effective and flexible solution. For applications requiring long-range control in challenging environments, cable trenching and plowing may be the more reliable option. Hybrid solutions that combine radio control and cable connections can also be considered to leverage the benefits of both technologies. In recent years, advancements in wireless technology have expanded the capabilities and reliability of radio control systems. Modern radio control systems utilize spread-spectrum modulation techniques to improve resistance to interference. Adaptive frequency hopping algorithms automatically switch to cleared channels to avoid interference. Mesh networking topologies create redundant communication paths, ensuring reliable connectivity even in challenging environments. Low-power wide-area networks such as LoRaWAN and Sigfox offer long-range communication capabilities with low power consumption. These technologies are well suited for remote monitoring and control applications in areas with limited infrastructure. The selection of a radio control system should be based on a thorough evaluation of the application requirements and the capabilities of the available technologies. Key factors to consider include the operating frequency, modulation technique, transmit power, receiver sensitivity, antenna type, and security features. It is also important to assess the vendor's reputation and track record, as well as the availability of technical support and training. Cable trenching and plowing remain viable options for applications where reliability and security are paramount. Modern cable technologies, such as fiber optic cables, offer high bandwidth and low signal loss, making them suitable for long-distance communication. Direct burial cables are designed to withstand harsh environmental conditions and provide long-term reliability. Trenchless technologies such as horizontal directional drilling can minimize disruption to the surrounding environment during cable installation. The decision to use cable trenching and plowing should be based on a cost-benefit analysis that considers the installation costs, maintenance costs, and the long-term reliability of the system. In summary, both radio control systems and cable trenching and plowing offer distinct advantages and disadvantages. Radio control systems provide flexibility, ease of deployment, and cost-effectiveness, while cable trenching and plowing offer reliability, security, and high bandwidth. The best choice depends on the specific requirements of the application and a careful evaluation of the available technologies. Before making a decision, it is recommended to consult with experienced professionals who can provide guidance and support throughout the design, installation, and commissioning process. Furthermore, regulations and codes may apply to the installation and operation of both radio control systems and cable installations. It is essential to comply with all applicable regulations to ensure safety and prevent interference with other communication systems. Proper grounding and surge protection are crucial for both radio control systems and cable installations to protect equipment from damage and ensure reliable operation. Regular maintenance and inspections are essential to identify and address potential problems before they lead to system failures. By carefully considering all of these factors, you can select the most appropriate solution for your long-distance on-off control needs. Remember to factor in environmental considerations when choosing between radio control and cable trenching. Trenching can disrupt ecosystems, so if environmental impact is a major concern, radio control might be preferable if it meets the reliability requirements. Consider future needs. Will the system need to be expanded or modified in the future? Radio control offers greater flexibility for expansion, while cable trenching might require additional digging and installation. Evaluate the long-term costs. While radio control might have lower initial costs, the ongoing maintenance and potential for interference could lead to higher long-term expenses. Cable trenching has higher upfront costs but potentially low maintenance costs over time. Research available radio control technologies thoroughly. Different systems have varying ranges, frequencies, and security features. Choose a system that meets specific needs. Ensure compliance with local regulations regarding radio frequency usage and cable installation. Failure to comply can result in fines or legal issues. Document the installation process and system configuration. This will facilitate future maintenance and troubleshooting. Finally, test the system thoroughly after installation. Verify that the on-off control functions correctly and that the system is reliable under various conditions.